Hello and welcome back! Now, let's imagine that we're doing some online shopping, alright? We're on a quest to buy new clothes, yeah? So, let's compare some products, alright? Which are you more inclined to buy? The t-shirt that's placed flat on the table or the t-shirt that somebody is wearing? Did you notice how the clothing worn by someone is more appealing than clothing laid flat on the table? Yeah? So there's something very important about having a human body to wear it. But what exactly are we looking for when the clothing is worn, right? What aspects do you look at when you're considering whether to buy a piece of clothing? So let's pretend that you and I are very much interested in this very lovely dress, right? The dress fits this model very well, right? Now, let's say you and I, yes, you guys included, we want to wear this dress. So what do we look for in this photo if we want to be sure it fits? So some of you might say, okay, maybe we want to look at skin tone, yeah, because this shade of red doesn't match all skin tones. Okay, so on this model it looks great. How about mine? Yeah, okay, the skin tone looks about the same as the model, so maybe this red dress, the color fits, right? Okay, good. How about you? Does it match? How about arm length, yeah? This is a long sleeve dress, right? So, the sleeves can be a problem if you have short arms, right? If you have short arms and you wear it, you look like you're doing Teochew opera. Right? So, if I compare the proportion of her arms to her body with the proportion of my arms to my body, I think, yeah, so far so good. Now, let's look at the waist, alright? So, our model here, wow, her curves go inwards. Now, you look at me, wow, my curve go outwards, right? So what's that gonna happen? If I wear it, the dress will definitely burst. So I definitely cannot wear this at all. Just from looking at her, you and I can tell whether you and I can fit into this dress or not. Have you noticed how we call people like her a model? That's because she carries out the same function as any model. Data is like clothing. On its own, we can't tell what's going on. Like it's like putting clothes flat on a table. So we need a human body, a model to structure it, to give it shape. All models structure data in a simpler way, making it easier for us to understand and to predict. Of course, models don't always give us the right answers all the time, but a good model will give you a good estimate of what you're trying to predict or achieve. Models come in all shapes and sizes, from humans to pets, tables to equations and more. In fact, in the previous lecture video, we've seen how we can model our data in certain ways, like a small table telling us about averages and stuff. In many courses, you'll learn how to use specific models, but this won't be very useful as a large part of computational problem solving requires us to abstract and build our own simplified models. So I'd like to cover the foundational processes required to model from scratch. Before that, here's a question for you. What is the color in your head when I say the sky is cloudy? White? Grey? Can it also be blue? Yes. How about purple? Yes, can, right? So this is a very strange thing, right? I say that the sky is cloudy, but you and I may have very different colors in our minds, right? This is a problem that arises whenever we try to translate something from reality into words. Translation is never easy. Now, let me tell you a funny incident. Many years ago, Star Wars Episode 3 came out, and then there was a bootleg copy, a pirated copy that went viral. So what happened was that the pirates took the English movie, added Chinese translations to it, and then they translated the Chinese back into English subtitles. Well, hilarity ensued, of course, because Star Wars 3, The Revenge of the Sith, became the backstroke of the West. If you watch Star Wars Episode 3, there's a scene where Anakin Skywalker wakes up as Darth Vader. He fell into the lava, and so he had that operation and all that. He wakes up as Darth Vader, he screams, "No!" But the English translation says, "Do not want." So translations are always very problematic. We lose meaning along the way whenever we do carry out this process of translation. Here's one problem that we will inevitably face when we're trying to solve problems computationally. We actually have to engage in a two-step translation process. First, we need to translate the problem into a simplified model that we can easily understand and solve. From that model, we need to translate that solution into an algorithm. Two-step translation process, two-step distortion process along the way. It's one thing to be coming up with a solution. It's another to take a step back and critically reflect on what we're doing, whether we are doing anything right or wrong. So in order to carry out the process of modeling, we'll need to apply pattern recognition and abstraction together to translate our problem from the real-world problem into an abstract model. Now, I don't just want to teach you how to reason using computational thinking processes. I also want to teach you how to reason better, whether computationally or not. So, let me introduce you to 3 very useful and powerful conceptual tools to help you gain conceptual clarity when you're carrying out the process of abstraction. The 3 tools, they are necessary, contingent, and sufficient. So when we ask whether something is necessary, contingent, or sufficient, we are forced to take a step back and reflect on what we are trying to define. Now, let's try Hainanese chicken rice. Yeah, it's a local delicacy. Okay, so let's look at a few samples of Hainanese chicken rice and carry out pattern recognition, shall we? What's common between them? Okay, minimally, there must be chicken, there must be rice. It's in the name, after all. These are necessary conditions, yeah? Chicken and rice are necessary to Hainanese chicken rice. We use the conceptual tool of necessary to check whether a condition must always be true for something to be so. Now, you notice some pictures got sliced cucumbers, some have chili, some have a bowl of soup. Are they necessary to Hainanese chicken rice? Not really, yeah. They're what we call contingent factors, yeah. They're contingent conditions. Contingent means that the condition is not necessarily true for something to be so. So we don't need them for our chicken and rice to be Hainanese. All that's necessary is the presence of chicken and rice. But is this definition sufficient? This means that we have said all that needs to be said. Let's say we're not sure. So let's look at other similar cases that satisfy the conditions of chicken and rice. Look at this. Are these Hainanese chicken rice? We do have rice and chicken necessarily there. Yeah, so they all have chicken and rice in them, but they're not Hainanese chicken rice. Yeah, so the chicken and the rice must be cooked in a certain way to count as Hainanese chicken rice. Now, this is not a cooking show, so I'll spare you the details on how exactly to cook Hainanese chicken rice. Now, at this point, let's take a step back and recognize just how much we use pattern recognition and abstraction all the time when we form ideas about the world. We look at patterns, we identify what's common, and then we form an abstract model of it in our minds. Imagine that you are developing a device to detect when grandma, who's alone at home, falls down. So no one's at home to look after grandma, right? So we want a system to detect when she falls. How would you detect a fall? Let me show you a few examples of grandma falling down at home. Ayya! 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 Using pattern recognition and abstraction, what is your detection model? You might say a fall is detected when grandma suddenly drops flat onto the ground and remains there for a long time. There are many problems here. First of all, grandma may have had a bad fall but managed to pick herself up within 5 minutes. Or she might have fallen in a way where she didn't fall flat. Or maybe grandma could just be doing yoga. Why? Grandma cannot do yoga, is it? Some grandmothers very cool, yeah? What happened here? We were just modeling based on what we have observed. We can only abstract from what we know, from what we have seen. It's difficult, almost impossible to preempt the unknown or to include the unknown or yet to be observed into our models. So we need to be very, very painfully aware that the models we create to understand the world or to solve problems are not 100%. There is always something unexpected lurking in the corner waiting to unveil itself to throw us off. But the point here is that no matter how much we try, our models are doomed to fail in some way or another because it's just so hard to catch every case that's out there. If we loosen our precision, we end up with a model that includes a lot of irrelevant things. If we tighten our precision, we end up excluding a lot of relevant things. Well, no model is immune from such mistakes, yeah? Models are like that. So we mustn't be complacent just because it works. That's a really, really low bar for success. Our model may fail. So what happens if the model were to affect human lives or livelihoods?